Okay, g'day students, and welcome to our lesson on working with ratios. So the point of today's lesson is you should be able to divide a quantity in a given ratio and find unknowns using ratios. The key ideas for the lesson is that when dividing a quantity in a given ratio, follow the steps. Number 1, find the total number of parts in the simplified ratio. 2, write each part of the ratio as a fraction of the total number of parts. 3, multiply each fraction by the quantity and then simplify. And 4, check your answer by adding the individual amounts and see the overall result. See that the overall result is the same as the original quantity. Now, equivalent ratios are formed by multiplying and dividing each part of a ratio by a whole number. Now, equivalent ratios can be used to find an unknown value. So let's have a look at the first one. First example I want you to consider is dividing a quantity in a given ratio. So let's divide 3,600 in the ratio of 3 is to 6 is to 1. What you can see straight away is that there are a total of 10 parts. One person gets 3 bits, another person gets 6 bits, and another person gets 1 bit. So that's a total of 10 parts. Now we want to consider that as a fraction. So we're going to say, well, one person will get 3/10, another person will get 6/10, and another person will only get 1/10. So now we need to work out what 3/10 and 6/10 and 1/10 of each of those are. So as you can see down here, we'll just do the first one with you. So 3/10 multiplied by 3,600 for this person. Yeah, so 3/10 times 3,600, and that's going to be 1,080. If we do the next one, 6/10 times 3,600, that should give us 2,160. And if I'm looking at 1/10, well, that's going to be easy, isn't it? It's going to be $360. But we'll just write that out, $360. Now you do need to check. So does 180 plus 2,160 plus 360 all equal 3,600? So that's your final check. And yes, they do. So the next example for you to consider is to find the value of A in the equivalent ratio statement. 3 is to 7 equals A is to 64. So what do I need to know is which side of the ratio or the equivalent ratio am I looking at? Am I looking at the left-hand side or the right-hand side? And you can see that it's the right-hand side of the ratio sign. So the next thing I want to do is think, oh, how many times does 7 go into 84? So I could go 84 divided by 7, and the point of those primary school times tables was for you to remember things like this, so this is easy for you. So okay, we know that 7 times 12 equals 84. So to make this equivalent, if I'm timesing the right hand side by 12, I'm going to have to multiply the left hand side by 12 as well. So 3 times 12 is 36. So the equivalent ratio of 3 is to 7 is 36 is to 84. So therefore A equals 36 in this condition. Okay, now let's write a comparison as a ratio in the simplest form. So first one we're going to involve decimals, and the second one we'll look at fractions. So write each comparison as a ratio in the simplest form. So what we want to do is just get rid of this decimal. So we'll multiply both sides by 10. So this is 0.4 is to 1.8, and that's the same as saying, well, 4 is to 18. Now we can simplify that because both sides are divisible by 2. So 4 divided by 2 is 2, and 18 divided by 2 is 9. So that's fairly straightforward. The next example is two fractions, so 3/4 to 3/5. So what we want to do is we want to find common denominators, and I'll leave that thinking over here on the left hand side as well. So what is the lowest common denominator for quarters and fifths? Well, I could say 4 times 5 equals 20, and that's a quick way to do it. So let's go and convert this now, 3/4 into 20ths. So 3/4 times, I said 4 times 5, so 4 times 5 is 20, so 3 times 5 is 15, so I've got 15 over 20. So if I'm thinking of the working, 3/4 times 5 over 5 is the same as 15 20ths. Now I find a few students get confused at this stage, because 5/5, it's the same as just saying 1, so any number multiplied by 1 is itself. So that works out to be legitimate in this case, but what's important, that it's also equivalent. So that equals that, because any number multiplied by 1 is itself. Now if I'm looking at 3/5, I'm just going to have to convert this to what? Times 4 on the bottom and times 4 on the top. So 3/4 are 12 and 4/5 are 20. So 12 over 20. The next thing we do is just remove the bases. And we're saying, oh well, that's the same as 15 to 12. And so there we go. And then we just simplify. What number goes into both 15 and 12? 3 does. So we say, well, 15 divided by 3 is 5, and 12 divided by 3 is 4. So we say 5 is to 4 for this. What else do we just need to think about? This is ratios, yep. So let's just have a look at a couple of other important statements about this. Ratios compare units of the same kind, and ratios can be converted into fractions of a portion of the total number of parts. So this is what I want you to copy today. So if we want to convert the following into a fraction, the following ratio into a fraction, what do we do? 3 is to 5 is to 4. Well, 3 plus 5 is 8, plus 4 makes 12. 12 parts. And then you just choose which proportion out of the total, turn it into a fraction, and then simplify it. The next thing is a little bit more of a thinking question, and you'll find this a bit more of a real life application. So if we want to divide a profit for 3 partners who contribute to 3,000, 5,000 for 4,000 into a business, into appropriate shares. Well, isn't this just the same ratio as up here? But I just put thousands on the end. So, well, partner 1, well, they get 1/4. That's the same as saying 1/4, isn't it? I can just cancel out those and then divide both sides by 3. So that would become both top and bottom by 3. So I can think of it like that. So 1/4 of $18,000 is 4,500. And then you just do similar for the others. Now when we compare ratios, for example, 0.4 is to 1.8, convert to a whole number. So we're going to multiply both sides by 10 because they've just got 1 decimal place, and then simplify by dividing both by the highest common factor, which is 2 for there. For this one, like we saw here, we want to convert to common denominators. So we do that, we convert it out to 20ths, and then we're going to remove the bases to become 15 is to 12, and then we'll simplify both by dividing both by the highest common factor. When you're all over that, students, can I get you to work on the mastery exercises for the lesson, please?